code because I haven't got to my desired rank of top 100. So now let's see. Yeah, I'll just be doing a few short puzzles, maybe for about an hour. And yeah, feel free to ask me any questions if you have. But I'll mainly be coding in Python and Ruby. Okay, I mean, eventually I will start coding in C++ as well to practice a bit for like those competitive programming competitions. But as of now, it is time to push rank. So, yep, all the best, everyone. Wonder if for realist is a bot. Oh, no, it's not. Oh, I know this guy, King of Delphi. Hello. All right, we're gonna start soon. Okay, fastest mode. You are given a value x in base n. Output this number in base m. Okay, the first one is x in base n, the base of value x. Okay, so I guess what we'll do is we'll convert the first number into integer first. Yeah, by doing this, int xn, convert it into an integer. Okay, so after that we make it a string so that we can apply the same conversion to base m. Wonder if this works already. Oh, did I miss out? Oh yeah, I miss out one more bracket. Yeah, invalid string literal for base 2, 5. Okay, in 5 in base 10. Okay, let's just print out this first. Print in xn. See whether this works first. This prints out 5. Okay, then if I will want to print out this in base 2. Okay, let's say this is a 5. Okay, let's convert this to a string. Invalid literal for int with base to 5. Okay, so if I want to convert this to a base, okay, Python int base conversion. Yeah, it's just like this, right? So I'm not too sure why this is not working because uh, string 5 comma 2 should work. Hmm, I wonder why this doesn't work. Yeah, this is supposed to work. Okay, let's hide this first. In 5 to. Okay, how about this? Does this work? If not, I have to implement the base conversion myself. But I think there should be. Is there a way to do like an integer? Yeah, built-in function to change the base of an integer. I guess I have to do my own built-in function. Yeah, I wonder if there's a way to do it without this method. Yeah, so one way is to use like binary and octal like this. Oh, is there such a thing? NumPy.base representation. Okay, let me just search that. Yeah, I was about to like code out the thing myself already. Ah, yeah. Thank you so much. Yes. Okay, let's just do this. So, so basically, we take this numpy dot base representation and then we convert it to that number. Okay. Okay. The operand type is an integer, so I don't have to do a string like this. Yeah. So this will give me an integer in base whatever. Okay. Okay. So I guess I need to do like dot lower. I guess. Yeah. Okay. So this works. Thank you so much for the suggestion, Zombie Killer Whale. Yeah, I didn't know about this MP dot base representation, but this is quite cool. This seems to be better than the default one because the default one can only convert it from a certain base to decimal to base 10. But this NumPy based representation seems to be able to convert to others. If not, I have to use like stuff like binary, octal, built-in functions, but that is not good enough for this clash. Okay, so let's see how the others did it in Java. In Java, there's okay. You can pass in to convert it to that particular base, and then when they did a toString, you can do this. Java seems to be Java seems to be like better. Why doesn't Python have this inbuilt? Yeah, why doesn't base conversion to string Python? Why doesn't Python have this inbuilt elegant inverse function? Let's see this. Yeah, looks like there's only this. Yep, NumPy based representation is the toString method for Java. Uh, yeah, they all use the same code for Java. Integer dot toString, integer dot pass in. So actually, Java does have some interesting stuff. I wonder why this didn't work. I dot is digit else ordinal I percent 32 plus 9. I guess this is to convert to the base, but why using this method? I guess percent 32 because like if you have a digit, then you add the digit. If not, if like A, B, C, D, E, F, regardless of small letter or capital letter, when you do a percent 32, the ASCII based representation, maybe let's search the ASCII table. ASCII table. Yeah, the ASCII based representation would convert it like capital A is 1 and small letter A is 96, also 1. So this were 1, 2, 3, 4, 5, 6. Yeah, so that's a shortcut way of doing it. Yeah, so this method looks correct. Yeah, I wonder why this didn't work. Yeah, well, the string k plus r. Okay, so you take the modulo for the new base. R equals to string k plus r. Okay, this adds whatever that is in here. Oh, I know why it didn't work because um, this only works if it's like only digits, right? Yeah. If it's like hexadecimal, you have to convert this to a letter. Yeah, that's so weird. Yeah, I thought Python is like the best language, the most convenient language. But it turns out that JavaScript has a better function for toString than Python. That's disappointing. I think we need to add this to the Java print method. Or at least like the int method, reverse int. I don't know what you call that. Base converge. Oh wells. At least NumPy bothered to do it. I mean, it's not a difficult function to do. It's just more convenient for people if they want to do base conversions. And it also means one thing: people who use Python don't normally do base conversions, or rather, they only do like maybe binary octal. Yeah, that's why this function wasn't really considered. Uh, if people use it more, I'm pretty sure the Python developers would use it as a base function or implement it as a base function somewhere. All right, let's try again. Yeah, that clash wasn't that great because I didn't know the function. Oh, a 15-year-old Australian pursuing an interest. Very nice. Oh, damn, I'm almost double his age. 15-year-old. Wow. I wish I was young again. Yeah, let's wait a while for more people to join. I like having clashes that have full people. Yeah, because it's more fun that way. It's more satisfying when you win also if you win with a group of 8 people. All right, you add numbers, find the square root of the smallest perfect square number. Oh, what is a perfect square number? It means it's like when you square root it is the okay. Hi, can you hear me now? I'm talking right now. Are you able to hear me? Is it because my environment is too noisy? Yeah, okay. At least there's one person who hears me, so it's not my mic issue I had, I guess. Okay, so this is a perfect square. Okay, I can tune up. But if I scared if I tune it up, it might be quite noisy because there's some lightning outside. Is this okay? Is this okay? I just increase the volume a bit. Okay, let's try to solve this problem now. Okay, so we have some numbers. So we want to find the smallest perfect square number. Okay, so what we will do is, okay, maybe we have all this here. Let's just put them in a list, I guess. Yeah, yeah. Let's put them in a list. Okay, and then maybe we just like sort the list for num in L. Okay, so maybe we just put lowest is 0. Okay, if is perfect square num. Okay, what we do is we'll print out this num. Okay, we print out the square root of this number. So we need to print out math dot square root num. So like here 16 is the smallest. Okay, and then maybe we exit. If not, then we'll print 0. Actually, then I don't need to have a lowest here because I actually sorted the answer. So we need to do now the is perfect square method. So what this is perfect square will be require x. So what we'll do is uh, square root equals to math dot square root x. Okay, and then we convert it to an integer. Maybe we call it sqr in that case. Yeah. Return sqr times sqr equals to x. That would mean that it's a perfect square, I guess. Okay, so print int. We need to convert it to an integer. So this should do it. And yes, this did it. Yeah. So basically, I just looked through. I sorted the list. I mean, I didn't need to sort the list. I could also do a for loop, and then I just update the lowest number accordingly. Yeah, and then if there's no lowest number, maybe the first lowest number can be -1. Hey, hi, King of Delphi. Yeah, doing great, doing great. Yeah. uh, Decided to do a relaxing stream. Yeah, to me, Clash of Codes is quite relaxing. Yeah. Recently, I've been doing some deep learning stuff. Yeah, trying to implement some new code. I'm taking some Coursera courses as well, so I'm doing great. It's an interesting field out there. Yeah, lots of stuff to learn. Ah, yes, yes, you can do that. You can do that. You can map to you can map to the square root and check whether they are integers. And then you still need to do some arrangement of the list so that you print out the lowest. Yeah, you could do that as well. For yeah, you're right. Is it very noisy outside? Because there's some lightning and I mean there's some thunder outside. I hope it doesn't affect my voice here. All right, so let's go. The Japanese abacus called a soroban. Oh, I didn't know that. Soroban. Oh, in Chinese it's called suanpan. Soloban. Yeah, suanpan. Soloban. Okay, sorry. Let's go back. Okay. Each column has one bit above the bar and four below. And this, yeah, it depends. The square root will not return an integer actually. It will return a float number. Yeah. Okay. Each column has one bit above the bar and four below. The bits may be moved freely up and down. Okay, the column represent each lower bit represents one. Each upper bit is five. We display as many columns as a soroban as necessary to represent the integer. So three, or this one up there, if it's up there means it's zero, down means five. So it's three over here. All right. So the input obviously is going to be a very large number, and I mean what we can do is we can actually just hard code this thing inside. Yeah. So we can just hard code the patterns. So maybe like mapping equals to sorrow map. Let's call it sorrow map. Okay, if it's zero, then maybe the first one will be a star score equals uh, um, I guess it's like that. Yeah, one will be this. Let's copy and paste this. One, this one will be like that. Two will be I mean the alternative is to like do an if else or do a for loop to map this, but no, I'm feeling a little lazy. Let's print out the representations like that. Later I'll then do a transpose. For would be like that. Okay, so we got all this already to four. And maybe over here we do this one will be six. This one will be five actually. Six, seven, eight, nine. So five, this one will be inverted like that. Okay, so we have our sorrow map or I in sorrow map. So I guess we have 1, 2, 3, 4, 5, 6, 7, 8. We have how many columns? 4, 5, 8 columns. So we have O equals to blah blah for in range 8. I wanted to say O, so yeah. So maybe for digits in whatever input we have in N. Okay, sorrow map int N. Oh, I need to bracket like that. Reference the dictionary. Okay, so pattern will be equals to this. And maybe what I'll do is I will add one by one here. For I in range 8, OI, okay, plus equals to pattern I. Yeah, then maybe we just print out the whole thing. Print pattern I. Does this work? In module 24, 31402. I forgot this should be digit. Okay, so this prints out the first thing here, 3. Okay. Oh, I should have printed out O, not pattern. Yeah, because O is the one that keeps track of my entire list here. Okay. Soroban. Yeah, so I just basically hard coded each column of the each column of the soroban or the abacus, and then I just have eight separate output rows. And then what I did was I just for each digit I just added to each of these output rows, and then I just print out the output rows. So yeah, that was just some trick so that I don't have to do it one by one. I could just do for all the digits like that, and then I can just um yeah, print out. I mean, the alternative will be you have a first row, and then you have this digit here. You check the digit, is it zero, then you print this. If it's one, you print this. You can also do it one by one, but I think a more efficient way would be to specify the entire column for that digit, and then after that you just maybe you could even do a transpose. You could just add this one by one to your rows in like a numpy array, and then later you just transpose it. That will work as well. Yeah, so there are different ways to do it. uh, nice. So that means I think I'll definitely quite a pro programmer. Pascal isn't easy to program. I used to do C. I used to do C back in my secondary school days. C. Then basically a lot of things we did in C were like inbuilt libraries in C++. So it was kind of a waste of time, or rather, I wouldn't say waste of time, but it's like just more primitive. Yeah. Pascal is also similar to C. Okay, you must output the absolute difference of between the number of consonants and vowels. Okay, I mean that will be simple, I guess. So what we will do is s dot counts a e i o u. I wonder if the count function prints out the. Oh no, yeah, it doesn't count one by one. Okay. Okay, so we do this. Count equals 0. Count plus equals 2. Okay, and then what we do is we'll print out the counts. Maybe we print out the absolute difference of counts minus away the uh, length s, which is the length of the input, minus counts. So that will be like the difference between the consonants and the vowels. Oh, okay. There's some, maybe there's spaces. Yeah. So maybe what I need to do is I need to check. Mm, okay, I think there's a way maybe to do this, like map is alpha to s. I don't know if I could do this. String dot is alpha. Is there a way to like count the, mm, when I sum this mapping? Yeah, okay, so maybe this is characters equals to this. So yeah, I hope this works. Unsupported type minus for non type and ints. Okay, let's see. Okay, because I printed it out. Yeah. Okay, great. Yeah, that's great. That's great. So yeah, let's count the number of vowels. I wonder if there's a vowel function, but if not, I think this was quite efficient already. Vowels, and then this one is to just count the number of characters, and this is to print out the difference between the vowels and the non-vowels, which is here. Okay, right. Let's go. Anyway, what are you all doing nowadays? Like King of Delphi or Circular? Are you all doing programming related things? Still a student or like working already? For me, I'm still a student, luckily. PhD student. Yeah, I like studying. Yeah. Are you a software engineer? Yeah, coding game is fun. Yeah, I first learned of coding game because I was trying to program AI, and yeah, coding game you can create your own AI. The bot programming competitions. That was how I first started coding game. It's called Coder Strike Back. Yeah, that's the first game that I programmed. That was pretty fun. Okay, we wait for one more. Who is this coding code? Coding code. Alpha Master Zero. Wow, sounds very dominating. Yeah. I'm actually looking forward to like this. I think it's either the fall or the spring challenge coming soon. Probably spring challenge. Yeah, looking forward to that. They create a suggestion engine given a list of predefined questions. Beginning of the question, give the list of questions starting with that prefix. How to get a girlfriend? Also it's like how to. So, no question matches the prefix, then print empty. Oh, okay. That's that's a challenge. Okay, I guess we can just check whether like this part and this part matches, right? There's a prefix, right? Question prefix is here. So like if if okay, so length will be the length of question prefix. I was thinking of whether I will want to use regex, but actually there's no need to. If row, wow, that's very fast. If row until length is equals to this question prefix, okay, then we just print out the row. Yeah, that's what we do. Oh, empty. Why is this empty? How to train my? Oh, am I supposed to print out empty? Oh, if no, nothing matches. If match equals to false, if match is false, print empty. Oh, there's this function starts with this is Ruby. This Ruby. I didn't know that there's this starts with function in Python. Oh, okay, okay. I guess my method works as well. I just basically just compared the first part, similar to Circular's code, where I just compared the first part. Yeah, yeah. Python is a utility. Python is super useful and super convenient. Yeah, I would suppose so. Ruby actually you can use regex. You can do like this, like dollar. I don't know if you can do something like that. Yeah. Oh, unrecognized command, but yeah. Anyway, let's go for the next one. Are y'all here? Yeah, yeah, yeah. Okay. A rabbit lives 4 days. Okay, second and third day, reproducing, making babies. Babies each day. The last day, dying at the end of the day. Rabbit being born on day one. How many rabbits will be alive on? Okay, so they reproduce, making babies. Right. Okay, this is a very big assumption here. I don't think rabbits can reproduce alone. But yeah, babies are born the day after rabbits reproduce. That's fast. Yeah, that's very fast. Do they reproduce in one day actually? Okay, so they reproduce 2 days and then they die in the last day. Okay, so let's just have maybe like day one rabbit equals day. Okay, let's just call it day one, day two, day three, day four. So the first one will be rabbit 0, 0, 0. So at day four they will die. So like for I in range day, so what we'll do is we'll have like the born rabbits equals to the day two rabbits times plus day three rabbits, okay, times the number of babies. Okay, and then what we'll do is we'll have this day one, day two, day three, day four equals to born day one, day two, day three. Okay, then we just print out the sum of all the days. Would this be good enough? 2640. Okay, so day two and day three. Day one will be born. Day two will be the day one rabbits. Okay, so my day one rabbits are rabbit, right? Day number of days to run the simulation. With rabbit being born on day one, maybe I need to run for one more day. I don't know. Count 2640. 10 rabbits born on day one. Okay, so this is when they are born. All right. Next, the next day, they will. The day two and day three rabbits will. Okay, maybe what I'll do is I'll just print out all this so that we can analyze the trajectory. So, okay, at the end of day one, this one will go to the second day rabbit. So the second day, this 10 will produce babies number, will produce 20. All right. So I'll move to that day, produce another 20. Oh, I see the issue because when this 10 produce 20, they are supposed to be like 10. This 20 and 10 is supposed to move together. So maybe what we'll do is we'll shift this one here first, like that. Two six four zero. Am I supposed to get 26? No. Okay, so my amount of bond, maybe this one should. Hmm. Maybe this one is day one plus day two, and I shift this one here. I'll just tweak with the formula until it works. Okay, so maybe I will shift this here like that, and then my bond is 0 at the beginning. Wow, what a big number. Day 1, day 2, day 3, day 4. So unless the original one was correct. Oops. Unless the original one is correct, I don't count the day 4 rabbits because they will die at the end of the day. Hmm. Okay, so at the first day, unless this is like day minus 1. 1480. Okay, looks like I've got it. Looks like I've got it. Looks like I've got it. I ran for one extra day. Oh, oh well. I didn't know. Yeah, I didn't know you only run for day minus one number of days. I thought it's days. I guess the first rabbit needed one day to grow up. Yeah. Why do you say thanks for my idea, King Delphi? Do you use my kind of code? Oh, okay. Yeah. You similar code. Yeah. R equals to R3 and then V plus R again. Yeah. I think the question wasn't very well phrased for the number of days. It was confusing, but I think I'll just leave it as that because in the real world, sometimes the problem statement can be a little misleading, but it's up to you to figure it out. Yeah. I mean, in this case, it works. Yeah. You just need to change this to day minus one. Okay. I think this is fine. Circular, are you going to be done soon? If not, we'll start another one. You can join the next clash. Is day minus one, by the way? Day minus one, number of days. Particle simulation. Yeah. This is a simulation based question. Okay, let's just do another clash. Okay, let's not waste time. All right, let's do another one. Let's do another clash. So, yep. All right. King of Delphi is here. Reverse mode. Oh, okay. It's come here, down, right, right, left, down. I guess V means starting position, right? Down, left, right, left, left. Oh, this is difficult. Down, left, down. I mean, how do I know which path to follow? Down, down, left, 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 down. Left, right, left, left, down. This is too difficult for reverse mode. I mean, there's so many paths you can take. How do you know which path to take? You see, like over here, when I go down, I can also go left and right, and it will still work. I guess there's a formula. If you can go down, you go down. Okay, then after that, if you cannot go down, you go left or something like that. There must be a way. You see, this even loops. Okay, so this is not an easy problem because like yeah. So I guess you prioritize based on what I see here. You prioritize going down first if you can go down. Then if there's a left and right, you prioritize going left. Then if not, we'll go right. Okay, so let's just do that simulation. Okay, so we have like this. So okay, begin equals to force. Okay, if s dot find v. Okay, I want to see the Python find method. The Python find method would give you minus one if the value is not found. So that's great. If string dot find b not equals to minus one, okay, begin equals to true. Okay, then what we do is s dot uh, find b index equals to s dot find b. Okay, if okay, then over here will be if begin. Okay, check first for left, then right. Check first for down, then left, then right. Okay, so what we do is if s index minus if s index is O, print down elif s index -1, and then we need to do a wraparound because you might need to do a wrap around like this case here. If this one is like that, then we print left. Okay, else s index +1. I guess we do a wraparound here as well. Luckily, Python's modulo function always returns a positive number. Print writes. Okay, and then else what we do is begin equals to false. So we just end the loop here. We don't need to evaluate anymore. So here, why is my index possibly unbounded? So index equals to -1, I guess. Yeah. Okay, let's try it out. Down, left, left. Oh, I forgot to do the condition here. Down, right. Oh, okay, then I forgot to update index. All right, all right. This was a difficult one, man. This is. Let's see. Fun was yes. Difficulty was too hard. Good. A little too hard to infer the rules based on shortest, based on reverse mode. Recommend only do so for fastest mode. Okay, yeah, I think that problem wasn't very well illustrated for reverse because like it's so hard to tell the pattern. Like there's so many possibilities of paths that you can take. Why would you want to go down when you can go left or right? Yeah, so in the end, it turns out that if there's a path that can go down, you go down. If not, if the left path is available, then left. If not, you check for the right path. Then, yeah. If let's say all three cannot, you will end your path there. And then you start with the B. I mean, this was obvious. This would be yeah. This was a difficult clash. Yeah, this this was a difficult clash. So yeah, good luck, King of Delphi. Yeah, good luck to you. Yeah, this not easy at all. I'll just play another one. Okay, you can catch me the next clash, I guess. Yeah, I want to maximize the amount of questions that I do in my stream time, as I only going to stream for an hour today. I'm going out later. Yeah. I mean, if you have any questions, if any of you viewers have any questions you want to ask me with regards to the code or like anything in general, please feel free to just type in the chat. I do check out the chat as well when I'm typing. Yeah. Okay, I'll definitely good luck for for that previous problem. I feedback that was too hard. Yeah. But I guess once you start a clash, you can't end it unless you complete it, right? So you have no choice but to complete that clash. Okay, so we just wait a while for more people to join. Ta-da-da. I wonder if I'll be able to make it to top 100 already with today's clash performance. I think I did pretty well today. I mean, normally I don't. No, wrong one. Normally I don't really check, but you see, quite a few first place today, which means there's hope to reach top 100. There's hope. Yeah. Yeah, we just wait a while for more people. Yeah. Okay, we are about to start. Let me just delete some of this. Shortest mode. Wow, it's been a while since we had shortest mode. Okay, find four unique positive integers whose square sum to n. Okay, this. Okay, can the integers be? Oh, yeah, it's unique. I mean, one way to do it is just to do a brute force. You can just brute force. It doesn't look like the numbers are very big. It's n smaller than 100, so you can do brute force like A, B, C, D can at most be 10. So it means that we can just like perhaps just like an array 1 to 10, we take out four numbers. Yeah, this seems like a permutations thing. In fact, I think Python might be short for this question. So let's try to do it in Python. Okay, so this permutation function, I think I'm just going to do it in Python. I'm a bit lazy to do it in Ruby. I think maybe Ruby might have a permutation as well, but that's my permutation operator. So if you do a it's permutations, you do the string, and then you do a comma, and then you do a number. So in fact, you can even do it like this range tree. Yeah. So let's try to do permutations. Okay. So I dot permutations. Okay. Range 10 4. Okay. So let's just print this out. So this will print out 0, 1, 2, 3, 4. Okay, looks good. So what we want to do is we have an input n, input n equals to int input. Okay, print star a. Okay, so maybe we do it if. Okay, so how do I do a square for this? So if I do a squared, what will happen? So maybe we do like something like ijkl, no, wxyz equals to a. Or actually, I can just do it here. Or for abcd, yeah, in this. If a squared plus b squared, c squared plus d squared, prints okay, there are multiple answers. This should be range 110. Okay, so all these are permutations of this, which is fine because we will go through this one first. So what we will do is we'll print this, and then we'll exit it. I wonder if there's a shorter way to do this, but I mean the most straightforward way I can think of is just using permutations. Mm, a dot permutation 2 dot 2a. Okay, this is 132 characters. Potentially can be like this, I guess. No, no, it's not possible. So 132 characters for Python. Okay, so now let's see whether I can do it shorter for Ruby. Okay, let's see whether Ruby has a shorter solution. Yeah, let me try it out. Let's go to Ruby. Oh, okay. Yeah. Okay, then there's a 130 characters then. Yeah. Okay, so let's try to do in Ruby. So we have an array of 1 to 9 dot permutations, I guess. Permutation 4. Can I do this in Ruby? Mm, or maybe it's a bracket. Not. Yeah, okay. 1 to 9 dot permutation. Okay, looks like the permutation is working. Dot permutation dot each. I wonder if I can do each for permutations. Yeah, I can do dot each. Yeah, hi King of Delphi. You can join the next one. You can join the next one. I'm gonna be finished soon already. Yeah, so I just finishing up this one here. So okay, so maybe we do n like that. For each of this 1 to 9 permutation dot each. Okay, can I do like A B C D? Can I do like that? Okay, yeah, I can. So what I can do is I can do square. I wonder if I can just do like x square like that. Can they do overloading? No, they can't do this. Map a square to the object. Yeah, yeah. Or in fact, can we do a sum? Yeah, yeah. Okay, we cannot do this because there's a underscore one inside here already. So like this, we do a dot filter. Then we just print out the first element of this. Should give me 1, 2, 3, 4, I hope. Okay, then I will just do a star here to. Okay, so I know what I can do. I can then do this star space. Can you scrub the? Oh yeah, yeah, sure, sure. Sorry about that. Yeah, so this is the question. You need find four unique positive integers. So put s Okay, 77 characters for Ruby. I wonder if I can do even shorter. This one is definitely necessary. Yeah, so I guess one way is to do this. That will shorten by one character. Star 1 to 9. Oh, does it work? Oh, okay. So this makes it an array already, is it? Oh, yeah, yeah, it works. Yeah, it works. Thank you. Yeah. So I guess this summation of this squared I cannot reduce anymore. And this one, I just wonder whether I can just do a dot each and then I print and then I exit. I think this is maximum n is 100. Yeah, so you can actually just do a brute force. Yeah, that's why I did from 1 to 10 or 1 to 9. I'm quite happy with this code already. I'm quite happy with this code. I'm not too sure whether it can even go shorter, but okay, I'm just gonna submit. Okay, I cannot think of how to shorten it further. Yeah. All right. 72 characters using permutation in Ruby, and then I filter out whether it matches the sum of all four numbers matches the sum of n, and then I just print out with spaces. I think that's the shortest I can do. I don't know. Well, do you think there's a faster, a shorter way to do this? I cannot think of any. This is the shortest I can think of. Okay, you want to do another clash? Yeah. Okay, I'm gonna start another one like right now. Wow, there's so many people in this clash. Oh, I know. I've seen Ali before. Ali Motada. Oh, yeah, n equals eval d. But will you get an integer if you do that? Eval will give you an integer, I guess, if it's all numbers. Okay, the logistics and military readiness of Zion depend. Oh, is this a matrix question? Network navigational beacons. Oh, thanks. Thanks. I didn't know that. Yeah, if you do an eval. Oh, it's okay. It's okay. I'll still be playing like one or two more clashes after this. The logistic and military readiness of Zion depend on a network of navigational beacons, each of which emits a beam in each of the four cardinal directions. Give the positions of the beacons, you must produce a map showing the beacons and the navigational. I have no idea what this question wants you to do. Okay, WH is the width and height of the map. All right, and then we have two of them, which is O if there's a beacon in that position, dash if there's a beacon somewhere to the east or west. Okay, so you're given two positions, 0, 2, and 1. This is a beacon, and 6 and 3 is here. So then you need to. Okay, okay. Yeah, I guess we'll just use Python for this. So we have a width and height. Yeah, I don't. Okay, I mean it's something. I guess it is. Shouldn't be that difficult. You just need to store where are the beacons. So you see x y equals to this. So um, beacon x-axis, beacon y-axis. Yeah, we can just do this. Beacon x-axis we plus this x coordinate here. Okay, maybe we just add it in as an array element like that. Beacon y-axis. Actually, I can just add like that. Yeah, maybe I just do an array element like that. Let's see whether it comes out as 2. Yes, okay, good. For I in range W, for J in start with heights, and then width. Okay, so we have the output layer like that. Okay, if if beacon x-axis I, I think what I can do is like that. Force for, and then here will be force for in range H. So beacon x-axis x equals to true. Because if you have multiple beacons in the same one, you just want it to be just expressed as one beacon. So if beacon x-axis 1 and beacon y-axis, okay, so this is actually the y-axis. So it should be J. This is the y-axis, 1, 2, and the x-axis, and beacon x-axis J and beacon y-axis I, then print plus, or rather O plus equals to plus. Elif beacon x-axis J. Okay, if there's a beacon in the, okay, so I forgot to do one thing. If this part here, okay, you still need to store the beacon position. Okay. X is I, right? So if it's a beacon, then we add O. Else, if let's say there's a beacon there, we add a plus. Else, if let's say there's a beacon in the x-axis, then we add this. Else, if a beacon in the y-axis, then we add a dash. Else, we add a dot, and then we print out the O itself. Okay. Invalid syntax. Not a function in line 11. Oh, I forgot to add a close bracket here. Okay, so looks pretty okay. It's just that this part here is not printed. So maybe let's print out our beacons to see how it looks like. Maybe I added it wrongly. Yeah, it's added wrongly. So I need to put a bracket here to append that thing properly. Okay, looks good. Okay, looks good. Okay, we have solved the beacons problem. Yeah, so just basically just check whether if it's a beacon, you add a O. If there's a X and Y axis that has a beacon there, and we do a plus. Thanks, Alfie. And if not, if there's a beacon in this X axis, we add a what do you call that? A straight line, vertical line. If a beacon in the Y axis, we add a dash. Okay. If not, we add a dot. Yeah. So basically, it's very important to do like this kind of false or true in two different axes, because there can be multiple beacons in each row and column, but you only want to count only one beacon in that column or in that row. Okay, because you don't want to like maybe have two beacons in the same row, then you count as two. So imagine if you have a sum of like beacons in row and column, you count as two. It need not be that there's one beacon to the north and south and one beacon east and west. It can be two beacons to the east and west. So it's important to have like a binary kind of indicator for the row and for column. So that's the main thing to take note for this problem. I actually quite like this problem, so I'm gonna give it a very high score. Nice. Okay. Oh, is it? But I quite like this problem though. Okay, I'm going to start a new clash. Did I start a clash? No, this is a rank. Yeah, this is a rank mode. So yeah, let's bring it on. Probably doing about two more clashes before I call it a day today. Yeah, it's been an interesting day. Hey, hi there, King of Delphi. How's your previous clash? The one that you entered in the wrong room. Oh, will join us. Good luck. This will be a difficult clash. Yeah, I mean we have pros here. You are the pros actually. Okay, let's see. Okay, we wait for two more. Nah, you are also considered very good. Yeah. Eventually, if you do it long enough, you will get better. Yeah, that's what I find. Like in order to start programming well, you just have to keep programming, keep learning from good code, keep learning from your mistakes. Yeah, copy paste is a skill, you know. You may think copy paste is an easy thing to do, but I can tell you, it is it's not that simple. You need to copy and paste the right portions to the right parts of the code. So that's a skill as well. In fact, you know, there's this AI recently, for Alpha Code by DeepMind, where they try to replicate the like human programmers in competitive programming. They did learn how to copy paste pretty well, but they still cannot solve those problems. So, copy paste is one way to solve some problems, but ultimately you still need to know some stuff. But copy paste is like a very good first step. Okay, I think I did this like 1 year ago. This clash, very familiar. Okay, neurology assigns numbers from 1 to 9, different dates of the years. 1 1 2 2 3 3 4 4 5 5 valid results. Add the digits in year, month, day. If the sum is 10 or greater, then add the digits again until you reach a single digit number or master number. Okay, only stop on the 2 digit repetitions. Okay, add three separate parts together, then repeat the process on the sum. Okay, so I guess what we'll do is we'll split this by a dash first, and then we have a day, year, month, day, right? Okay, so let's just call it reduce. Plus reduce, and then we reduce this one here. So uh, we just need to figure out what's the reduce over here. So the reduce here is will probably be a string. So x equals to, let's convert it to a string, regardless of what it is. We convert to a string. So sum equals to, okay, sum of this one int I for I in x. If s in 1 1 2 2 3 3 4 4 5 5, okay, return s. Okay, then x equals to s. Wow. If it's greater than 1, then we keep doing this. Okay, x equals to string s. Yeah, we keep doing this. Okay, so this is the way to reduce expected and indented line. Okay, did I miss out something? Miss out one more bracket, right? Oh, there's a while loop here. Okay, unsupported operand types. Okay, I forgot to return something. Return int x. Okay, so here 1111 will return as 11. Okay, and 1957 will return as 1957 10 plus 5 plus 7 10 plus 12 22. So this should return as 22. So maybe what I'll do is I'll print reduce. It's 22. So 22. Let's not reduce this first. Let's print out this. Oh, okay. Okay, I reduce my month to 11. Okay, so I need to do this check first. Okay. Oops. All right. Congratulations, definitely. I made a mistake there. I should have checked the 1 1 2 2 3 3 4 4 5 5 at the beginning rather than at the end. Yeah, so I made a mistake. Oh, some map chain. Nice. Yeah, you can map the chain to this. And then chain basically is my reduce method. And then you sum this up and then you chain it. Not equals to length x. So this is the way you check for repeating numbers. Interesting. Yeah, it's a very efficient code. Yeah, string sum map index. Very nice. Very nice code. Yeah, I mean, I did this. I could also have done map in x. Yep. Same thing here. You also did the map reduce to this. Yeah, and then you sum also, right? I guess sum. Yeah. Okay. Very nice code. Actually, your code could even be a contender for shortest code, although it wasn't the shortest mode. Okay, let's do one last one. Will, are you okay? I think. See, King of Delphi. I told you you were pro. You see, you don't believe me? Yeah. All right. Let's I do one or two more. I just click play again first. All right. So if this clash is a short one, maybe I'll do one more. If this is a long one, then this will be the final clash. So yeah, good luck everyone. Long clash are usually the shortest mode. Usually that will be the long ones. Okay, so we just wait a while for more people to join. Oh, actually, I can just okay. Just one more. Just one more. We can wait. Yeah. So it's either this is the last clash or one more after this if the clash is short. So all the best, everyone. And we just need to wait for one more person before we can start. Okay, great. Fastest mode, task to calculate numeric characters. The sequence is accepted and calculate alphabetic ones if not. What's an accepted sequence? And numeric characters only inside alphabetic characters, only on both sides, left and right. What does it mean by calculate numeric? Okay, so I guess this is not an accepted one. So if it's accepted, then I will print out the number of numeric, if not alphabetic. So this is alphabetic because it's not accepted. This one is okay, so print out the numbers. This one is not, so we print out the number of letters. Okay, so very simple. Uh, Alpha equals to sum n dot is alpha, sum dot string dot is alpha n. Okay, let's see whether this works. Oh, I forgot the map. I forgot the map. Silly me. Okay, so I mapped this one and there's a missing parameter. Oh, I should have put the brackets here. Okay, so this maps already. What I want to do is I need to then check whether the numeric characters are only within the center of the string. So how do I do that? How do I check whether the numeric are only within the center? So I guess we can just do this. For if ni dot is alpha is digit, break. I in range length n minus 1, 1 or 0, 1, 0 actually, 0. No, minus 1, minus 1. So it ends at 0. Okay. If ni dot is digit, n equals to I. Okay, and then we break. If n start to n, okay, dot is digit, okay, only when it's digit, then we print out the usable, we print out the number of numeric, we print out digit. Else we print out alpha. Okay, let's see whether this works. Okay, it works. Yeah, so I just take from start to end of the sequence and I check whether it works. Yeah, same thing. So break if within this is numeric. Okay, actually is digit will work also because is digit applied to a string will do it. Print sum for one. Oh, nice, nice. So actually it's similar code, but he coded it in like 1 minute faster than me. Yeah, this Kurtzy, he did it in 1 minute 40 seconds. No idea how he coded it so fast because the 1 minute 40 seconds was about the time it took for me to understand the question. So I guess he has coded this question before because that question wasn't exactly very well phrased. I feel, yeah, it took a while for me to understand. Yeah. Oh yeah, well I just saw your message. Took a while for you to understand that last question. The one on the numerology, right? The yeah, I guess I can play one more clash actually. Yeah, this was quite a short one. Yeah, so let's. Shall I wait for you, Delphi? I mean, if you are going to be done soon, I can wait for you a while. Yeah, so the idea is to just check the start and the end, and then you just check whether the in-betweens are digits. Or actually, a very simple way to do it will be to use regex actually. So if you use regex, you could do something like this. So if you can do a regex, you start with a dollar and then you do 0 to A to Z, A to Z, okay, and then you do a plus, okay, 0 to 9, plus, and then A to Z, A to Z, plus, and then you do the N character for the string. I forgot what's the N character. Dollar sign N. N is it? I forgot. But basically, we do a regex thing here. If you were to do this, oh, sorry, it's the other way around. It should be like this. It should be like this. If you just check that this is in the string, start to end like that. Okay, then you can then do, yeah, then you can do the counts of the starts and the end. So if you do regex, it's a one-liner or two-liner answer. So I guess maybe he used regex. Yeah, I mean, not 1 minute 40 will be a bit hard to do without regex. Yeah, it should be a regex answer for this. Yeah. Hey, thanks, Will, for the clarification. Okay. I think I will just, I don't know. Should I just click on the next flash? I think Delphi is currently working out how to solve this right now. Okay, let's just click on the next flash. All right. I'll start the next clash. So let's see. Um, let's see how difficult this clash is. So yeah, actually a lot of times in clashes, very. Oh, is it? You want to join the next one? Oh yeah, yeah, here already. Yeah, that one you have to do some form of like finding out where the start of the non-alphabetic strings are and where the end of the non-alphabetic strings are, and then you just check the middle part whether is it numbers. Or I mean, I was just saying just now, you can also use regex. You do a very simple regex actually. It's like this. You do something like this: A to Z, A to Z plus, and 0 to 9 plus, and A to Z, A to Z plus. I think you can do something like this, a very simple regex like this, and then you can just check whether or not you can do re.find and check this. Yeah, pretty sure you can use re.find, and then you check whether that or re.find match or something like that. Yeah. Oh, I didn't use regex, but I think regex would work for this. Re.search. I never really use regex in Python much. Yeah, so re.search, and we can do like that, match not equals to none. Find all, returns left to right. Okay, let's go back to the clash first. Fastest mode. Okay, left to turn left, right to turn right, or integer d2, distance to be covered. Okay, and integer n for the number of instructions given to the turtle. All right, so this is a simulation problem. Okay, and then containing either left or right instruction or distance to travel, and give the coordinate. So that initially the turtle is aligned on the horizontal axis looking to the right. Okay, so it's 50-50, and then three number of command lines. First move 10. So I guess the turtle will move to 60. Okay, and then move right. So he'll hit right, and then he move right. Horizontal is moving to the right. So 50-50, I move to the right, I get 60. And when I turn right, I become 40. That's a bit weird. It means, okay, let's look at another one. I move 10, then I do minus 30. So this is 20, 10 right, 10 left, 10 right, 10 left. Mm, I guess I'll just start, do a direction first. I'll start coding something first. So 0 become, if the direction is 0, it means a 0, 0, 1. If not, if I go to 1, which is turn right, then it will be heading south, right? So it's a 1, 0. If not, I have a feeling this going south, going right here, like I have a feeling that when he goes right and goes down, he goes to 40. So that means this is actually a minus 1. Then after that, 2 will map to minus 1, 0. Let's just try this first, see whether it works. And then this one will map to 0, minus 1. Okay, so we have a D map. Okay, okay, the command is input. If command equals to right, oh, that's very fast. Well, okay, D plus equals D equals to D plus 1% 4. Else, if command is left, okay, D equals to D minus 1% 4. Okay, else, okay, what we do is we'll do this. Okay, X, Y equals to D map times D map D times the integer of this command, which is the distance, plus the previous X and Y. And then we just print out X, Y. Too many values to unpack in this. D map D times in command. Let's see whether this works. Okay, so my D map D has a problem. Oh, because they didn't do the scaling here. I want to multiply the two elements. Okay, delta X. Maybe I do like that. Then uh, Y. Okay. Okay. So the initial part should be 1, 0. I guess I'll just flip this around. Okay. So this. Okay. Maybe I go back to X and Y like that. So when I face to the right, okay, I move my X like that, and then when I go down, I make my Y go down like that, and then after that my X will be like that, and then my Y will be like that. Okay, you all are really fast. Yeah. Okay. So we have this V0. Yeah, complex numbers. I knew I should have used this. Yeah. V minus 1 plus V minus 1. I don't quite get this. V minus 1 plus V is v1 dot dot, okay, plus this thing here. Mm, okay, okay. Yeah, it's a bit too complex for me. Yeah. Then we all use, yeah, so there's also this delta here. This is similar to what I did. P0 plus delta 0. Yeah, I know roughly the complex numbers thing. I just don't quite understand. I think if you multiply by j, that would be easier to understand. Yeah, than your code of rotating this list here. This is, I guess I can see it. Yeah, you're rotating like that. Then you add a zero, and then you rotate like that. Then you add a zero, and then basically this will give you either like a one or a rotated value. Okay, actually I can do one more. Yeah, let's just do one last one. Okay, you are fast. Yeah, you are fast. I think this question they didn't really mention that the y-axis going downwards is to minus the y value, but I guess it's inferred from the test cases. Yeah, based on how you do the rotation like that. Yeah, but that was a simulation based question. Yeah, there's quite a lot of simulation based questions nowadays. All right, let's go. Let's go. We'll join in at the last moment. Okay, let's go. Reverse mode. 0, 2, 1, 3, 2, 5, 3, 7, 4, 11. Is this a Fibonacci number? 2, 3, 5. No, it's not. 7 times 2 plus 1. 24 is 97. Oh, prime number. They already gave the answer here. It's the 0 prime number, first prime number. Okay. Yeah, but this one is up to 2500. Actually, we can brute force this prime numbers. Yeah, we can brute force this. So, okay. Just have a S here. Okay, then we have a return sum. Something like this in range 3i if we have a factor. So basically what we need to do is we will only have factors that is only the prime itself. So each prime should only have two factors like this. You can even do range 2i, I guess. Because even numbers will not be a prime. Yeah, so a prime will only have two factors. I wonder why this works actually, because like s plus equals to 1, right? Range 2, or so over here, because 2 wasn't a prime in my case, that's why it works. Okay, let's do this like that, and then like okay, I guess my prime numbers are calculated wrongly. Let's see what I calculated. 2 6 6 was a prime here also. Device a super smart prime number generator. But you don't have to worry that this is slow, right? Because this is like 2 2 3 4 6 3. Mm, no, this one should be until I plus 1. I guess I have to do the default way of doing primes. Alright, I guess I'll do the default way of doing primes. Yeah, and I do like 3 I, okay, and I. We check 3 5 6. In fact, we can do square I also. Yeah, I mean, what I normally do is like that. For I in range, for f in range 3, math dot square root I 2. Okay, if f I percent f is 0, then return false. Then after that, if everything passes, then we return true. I mean, this will definitely work. Quite sure this will work. Type error float object cannot be converted as an integer. Okay, so this one you just need to do an int. I think this would work. I don't have to print the primes. Okay, because this is the method that I'm used to. I know there's a shortcut method to do primes. Yeah, just not too sure what this is. Test 3. 3 is 5. Why is this? Why is this always with error though? Plus 1 maybe? Okay. Alright. Yeah, somehow my prime factorization wasn't exactly the best. Yeah. So yeah, I have to revert back to my default way. I just know that there's one way where we just count all the factors of a number. Yeah. And then if the factors of, because if it's a prime, there's only two factors, then one at it and itself. Okay, if it's not a prime, I guess I should have done from range 1, okay, range until that number itself, and then check whether there's like two factors. I guess that's one way to do it. Yeah, this is the way. This is the way. Yeah, if all I percent j, okay, for j in this range. Oh, okay, okay. This is this the sieve method? Yeah, this is the sieve method. Yeah, if basically you don't divide any of these earlier prime numbers, then it's a prime. Yeah, interesting. This is the sieve of iterator. Yeah, this is the sieve method, um, but with a longer runtime. because you need to do the for loop and the all twice. I mean, in the sieve method, you just go number by number every time you have a prime factorization. Yeah, this is a very interesting method. Well, I believe you use the is prime method in Ruby. Yeah, require prime. I remember this method. Oh, you can do this prime dot take what? You can do that. You can just take the instance of prime. Oh, okay. Oh, the prime method already has. I thought you would do this prime dot prime question mark. What was the code again? Prime dot take. I think it's here. Prime dot first. I know prime. I didn't know you can do a take. Okay, I guess dot take just basically returns that number. Yeah. But why do you do P 500? You just assume that you only do the first 500 numbers, is it? Is that how? Because it doesn't really make sense to just limit to the first 500. You should do for all the prime numbers in front. Yeah, I guess you just assume that the problem wouldn't ask um, for more than that. Yeah. Mm, yeah, you just assume that the problem wouldn't. If not, you can just do for p. You don't need to limit it. How about writing a function that gives one? Oh yeah, I don't know about that zeta function. I only know about the golden ratio, phi. Yeah, you can get the Fibonacci numbers one after another one. Okay, if not, actually, I've got to go. Yep. Thanks so much for playing with me, and I'll catch you around next week. Hey, bye, everyone.